Hello, and welcome to the third episode of Getting Started with Booster. In this episode, we'll be taking a look on how a Booster app is structured. If you don't know what's Booster and you still haven't watched, please go back to the first episode where there's an introduction to Booster and all the concepts that you require to know. So Booster is a framework, but it's a backend framework. So you'll be writing like the part that stores your data and works with your data for your front end, which is your website, your mobile app, or whatever. But Booster makes this super easy for even web developers or like mobile application developers that don't have much experience with backend. So let's jump right into it. So when you work with Booster, you will probably have a mobile app interacting with a GraphQL endpoint. I say probably because this GraphQL endpoint is provided by Booster itself. But you don't have to be worrying about it. I mean, you just have to know that this GraphQL endpoint exists. Nothing more. You don't have to be configuring it. You don't have to be thinking about how to wire all this stuff. Everything about that is configured by Booster itself, so you don't have to worry about it. So what can we do with a GraphQL endpoint? Well, GraphQL is a technology that somehow replaces, we can say, the actual HTTP endpoints. So when you work with a server, with a backend, you generally have to access endpoints. So for example, if you go to youtube.com/watch whatever, that will go into the watch endpoint, which is like a we can call that a sub URL of youtube.com. So when you reach that in the YouTube server, there will be some code that's executed. So with GraphQL, instead of having different endpoints for different things, so instead of having /watch/register/login, you just have one and you send to it some operation in a different way. So with GraphQL, you have a single endpoint, which is what Booster provides, and you can perform either queries to ask the server for data, or you can perform mutations that will ask the server to perform some actions on the data. So if you send a mutation to the GraphQL endpoint, it will submit a command. So everything that's being shown in the diagram is part of Booster. If I'm saying like stuff like mutations, queries, that's part of, for example, GraphQL itself. So if you don't really know about how these mutations and queries work with GraphQL, don't worry yet. We'll get to it in the last part of this series where we are testing our application. But if you're curious and you just want to know, just go ahead and look it on DuckDuckGo or whatever search engine that you prefer. But it's quite easy to grasp. So you just can not worry about that. So when we perform a mutation, which is asking our server to do something on the data that our application is storing, Booster will submit a command. So what is a command? A command, when we look for a kind of real life definition, a command is like an imperative order. So you can command your dog to sit, or you can command your instant messaging app to send a message. So those are imperative orders. And generally, when you're designing your app, you're thinking about what can my user do? Like, what are the actions that this user can perform? Most of them usually will be commands. So, for example, I don't know, create an account. That's a command because you're commanding your application to create something, or deposit money. That's also a command. It's you're telling your application, hey, I'm giving you this amount of money and I want you to deposit it. But you're sending something imperative. Commands are defined with TypeScript classes. So this command is just a little piece of code with some fields that represent the required information to perform this action. And these classes will have a handle method, and this is what we call a command handler. So a command handler is this method inside of the command class, and inside of this method we will write any kind of code that we want to be executed when this command arrives to our system. So for example, let's think about this. I want to create a command called create account. And I don't want to do anything. I just want to notify the user through email that their account was created. So my web application or mobile application, doesn't matter, will be connected to this GraphQL endpoint, and it will send a mutation called create account. So this GraphQL endpoint then will be submitting this command that we have defined called create account, which is a TypeScript class. And when this command arrives to our system, the command handler method will be executed. And in this command handler method, I can write whatever code that I want. In my case, I can just, use an email library or whatever, and just send them a message. So my command, for example, if I want to send them a message, my command probably will need at least the user email. So this will say, hey GraphQL endpoint, I want you to execute a mutation. This mutation is called create account, and it has the input email, which is, johndoe@a.com, and I just want you to execute it. So this GraphQL endpoint will then create your class underneath, and it will execute your command handler method. That's it. We'll be taking a look on how to do this, but just to get an overall idea on how does Booster work. We'll be revisiting this diagram once in a while, just to keep things fresh. But again, okay, we have executed some code, but we might need to store that an account has been created. So when a command handler ends, we usually want to register an event. So what's an event? An event is exactly in the same meaning of real life. Those are things that happen. So in the case of our application where we are creating an account, the event will be account created. So we're just saying, hey, this account has been created. It's a fact. It's something that has happened, and it's truth. So this over here represents the events store of your application. You don't have to be worrying about it, but just know that there is this place in your application called event store, which acts like a list or an infinite array of events. So you have all the events that have happened in your application. For example, account creator for user, blah, blah, account creator for using another one, or withdrawal performed, or money deposited. So you have this huge list of events that represent the things that have happened in your system. But you don't have to be worrying about it right now. Just know that it exists, and you don't have to be thinking about, okay, how do I store this? No. The only thing that you need to know is that when your command handler ends, you will be registering an event. And what's an event? An event, when we're talking about code, is also a TypeScript class. It's a class with some fields. So you just write the fields that you require, the name of your event, and Booster will handle everything for you. You don't have to be thinking about like special ways of structuring, connecting, or whatever. No, just a plain class marked as event, and then with some fields. We'll get to that. But let's suppose that we had written a command called withdraw money, and this command handler registers an event, money withdrawn. And it happens that the user's balance of the account is now negative. We have to notify the user. And how do we do that? Well, for that we have some special functions that act as trigger to some events, and they are called event handlers. So those are, again, some special classes that you write, that they have a handle method, and they are listening to a specific event. So in this case, we could write a class called, I don't know, negative balance notifier or something like that. Doesn't matter the name. And we're gonna say, hey, you have to listen for all the withdraw performed events. So it's gonna be listening. And in this little piece of code, we're gonna check if our current balance is negative. And if so, we're gonna send the user a message. So again, what's gonna happen here is that the user will be sending, well, our front-end application will be sending a GraphQL mutation called withdraw money. This will be converted into a command, which is a class in our code. And when it reaches our system, its command handler will be executed. This command handler will register the money withdrawn event. And then this event handler will be fired because it's listening to all the money withdrawn events. And in the case, if it's 0, it will notify the user. So, like, this is like a little utility to act on some specific events in your system. But again, we've been talking about balance, and we don't have a balance per se in our system. We're talking about events. And in some way, when you work with your bank account, there's no such thing as balance. You have your list of movements, and you can say, hey, you have your list of movements, and you say, hey, I want to know my balance in July. I don't know, 23rd, I don't know. And what the bank is going to do for you is going to take all the events that have happened in your system, and it's going to combine them into your current balance. So for example, you have account created, your balance is now 0, money deposited, I don't know, for example, 100, money withdrawn, 20, and now you're going to say, okay, now I want to know my balance right now. So your balance will be 80. And this combination of events is called a reduction. And this is when you write a reducer for your events. And here, when I say reduce, and you might be thinking about the array.reduce method from JavaScript, or whatever reduce from any language. There's also some languages that call this fold. When you reduce, it's exactly that. You're taking all the events and you're combining them into a single thing. So what's this thing called? It's called entity. So an entity is this some kind of state at some point in time. So you don't have an entity as it is. You have an entity at some point in time after some event. In the case of a bank account, you would have, for example, an entity after 4 events, or 2, or 1 million. It doesn't matter. So in our case, our entity will be the account. So when this event handler wants to know what's our current balance, it will ask for the entity snapshot. Snapshot, what's that? Booster, each time that some events happen, will be creating a snapshot. A snapshot is like when you save a game on a video game. It's like some point in time saved specially to resume from that. Imagine that you have, I don't know, 4 years of events and you want to know what's the current state of your bank account. You would have to reduce all those events, that could be millions. But Booster will be saving periodically these entity snapshots. So instead of starting from scratch, your reducer will start from the latest entity, which is much faster. And thanks to that, we also can access these snapshots from event handlers and command handlers. Like to do stuff like we said before, like balance is negative, and we want to notify the user. But we'll get to that in the code. So these entities are here in the middle of nowhere, and they represent somehow the internal state of our system. We might have, I don't know, some data that shouldn't be public. For example, addresses or passwords. Please don't store passwords in plain text, as a side note. But I mean, just as an example. So what can we do to access this state from outside? Because, for example, I don't know, our mobile app might want to know what's the current balance. And here is where we write what we call a projection. A projection, same as a command handler, same as an event handler, same as a reducer, is a method. A method that will take an entity and will remove like private data, transform the entity a little bit. This is a function that you have to write, and it's used to like clean your data, like to give it the shape that you really want for the front-end application. I don't know. Let's suppose that you are storing the balance in a string here in text for some reason, but your mobile app needs to know that in numbers. So in this projection function, you can take that entity, take that state of your system, like private, the internal state of your system, and transform it in what your front end is expecting. So you will write a projection, which is a little function, as we said. It will take this entity, and then this projection will write a read model. A read model is another class like entities, events, commands, which is then exposed to the public through this GraphQL endpoint. So here you will specify what is. So here you will specify what is the data that your user will be like able to look at. So, for example, if you don't want to expose addresses to the outside world and you just want to keep them internal for any reason, you can do that. You just write a projection that strips that field of the entity and creates a new read model without that field. And then automatically all those read models are exposed through this GraphQL endpoint. As we said in the beginning, GraphQL has 3 basic operations, which are mutations. Here we use in Booster mutations for submitting commands. But then we have also queries and subscriptions. So when this GraphQL endpoint receives a query or subscription, it will query or subscribe to a read model. So our front-end application here can say, hey, GraphQL endpoint, I want to query some data. The data that I want to query is bank account read model. And I only need the balance field. For example, I don't need the owner name, I don't need the address or the bank address or whatever. I just need the balance. And that's done here from your front end. So you don't have to be worrying about writing very complex stuff. So if you are looking at this and you see different colors, in fact, there are some kind of separations. For example, this orange part over here is the write part. Here is the part that our system ingests the requests from the user or the application. And here we perform validation, we connect with other services, with other APIs. For example, I don't know, we are writing our bank account, but at the same time we have to connect to some other service to perform, I don't know, validation, auditing, or whatever thing that could be that place. I don't know right now. So this part is the part that validates all the inputs and then writes into our system. So this is the write part. And what does it write? Well, it writes events, which then get into this reactivity part. So we have this part that is constantly reacting to stuff. So we have events, we have like event handlers that are reacting to events. We have reducers reacting to events as well, writing entities. And this is like the internal flow of the data that you use to transform stuff. For example, you can take events, fire event handlers, create more events, and fire more event handlers. You can do crazy stuff over here. Don't worry, we'll get into that. And then you have reducers to create the state of your system. And then last but not least, you have the read part, which is the one that allows your users to access the data from your system. And that's mostly it. That's the basic structure of a Booster application. So this video is already quite long, so we'll end up it over here. And in the next video, we'll be taking a look on how to design our app with all this structure with commands, events, entities, read models, etc. And how to create our first Booster project with code and all that stuff that you need to start.